Today we're going to be answering problems involving confidence interval for population proportion. So the first problem that we're going to be working on is identifying population and parameter of interest. Now the first one, which is the population, for this word problem, for letter A, the population is simply all undergraduate students at a large university. And the population or the parameter of interest will be the one that we're estimating, and in this case, the proportion of students who are willing to report cheating by other students. So this is how we identify population and parameter of interest so that we can start working on constructing our confidence interval. Now the second part of the work is to write the conditions of the confidence interval for the parameter, and the parameter we're using is the population proportion, and there are three conditions that we need to satisfy. One is that the sample should be random. Two, we also need to test that the independence condition is also verified. And lastly, normality. So for randomness, we have an SRS of 172 undergraduates, so it already satisfied the condition because of that. So we have an SRS of n equals 19 undergrads. And for independence, since the population will be all students at a large university, we can assume that n is greater than 10 times the sample size of 172. So these two conditions are easy to satisfy. Normality, however, needs a little bit of computation, so we need to show what p hat first. And p hat would be the proportion of the undergraduates who are willing to report cheating. And in this case, 19 of them answered yes, all over the sample of 172. So 19 divided by 172 is giving us 0.11. And Q, which is 1 minus p hat, is equal to 1 minus 0.11, which is simply 0.89. So these are the two values that we're going to be using, because to show normality, we need to show that NP is greater than or equal to 10. And NP in this case is 172 times 0.11. And using our calculator, it's going to give us 18.92 is greater than 10. So that was why check whether it's also greater than 10. And then is 3.08. So with this, we're able to satisfy all three conditions. So we are safe to use the confidence interval procedure to estimate our population proportion. Now let's answer problem letter B. For problem letter B, we're going to compute for the sample size or desired sample size given the confidence level. So let's go ahead and organize our work by writing out all the given information. So we have the p hat, which is 75%, or 0.75. Therefore, Q will be 0.25, and we're going to use that later on. We are also given the confidence level of 90%, and we're going to use that to find our Z star, because since we're working on proportion, so we're going to be using the formula for confidence interval for proportion, which is p hat plus or minus the critical value multiplied by the square root of PQ all over n. So we know in our formula that this is our margin of error, and in this case the margin of error is also given, so we're going to use that later on in our formula. Now, since our formula is in general form, let's go ahead and derive the formula for finding the sample size using the margin of error. So let's equate the margin of error to Z star times PQ all over square root of n. Now that we have this formula, we can cross multiply the square root of n. I just modified it so that you will see that we can get rid of n later on in this formula using algebra. So this is square root of n equal to Z star times square root of PQ all over the margin of error. So this is the formula that we're going to be using. We just need to figure out what Z star is, and to do that we're going to be using our confidence level. So 1 minus 0.90, since we are using that confidence level, divided by 2 is going to equal to, using our calculator, 1 minus 0.90 divided by 2 is 0.05, and we're going to use that Z star at 0.05 using our calculator. Second function, vars, inverse normal, 0.0501 by default is 1.64. 1.645. Let's add it another digit. So 1.645 is our value for the Z star. Now we're ready to compute for the sample size. So square root of n is equal to 1.645 multiplied by the square root of 0.75 times 0.25 all over 0.04. Now by using the calculator, so I'm not going to show it because I already worked it out a while ago. If you use your calculator, this will equal to 17.7968. But since we are looking for n, not the square root of n, we're just going to square both sides. So n is going to equal to 316.73 or 317 samples. So this is the sample size that we need to be able to construct a 90% confidence interval given the information that is given to us. So that now for problem number 3, we're going to be computing for the confidence level. The information that's given to us, because this is a confidence level for proportion, we have the sample size, we also have the value of x, and the margin of error. So if we have n is equal to 5,594 and we have x of 3,547, which is the number of people who will participate in this particular study, we're going to be finding p hat by dividing 3,547 by 5,594 and using our calculator. 3,547 divided by 5,594 is 0.6340. So let's just use 0.63, and our q, which is 1 minus p, is the complement of 0.63, which is 0.37. So we have our P and we have our Q, and we know that we're going to be using our formula again. For confidence interval, we have P hat plus or minus Z star times square root of PQ all over N. So this is our margin of error. So just like in computation of the sample size, we are going to derive our formula using this. So we'll have the margin of error equal to Z star times square root of PQ all over N. Since we are working on finding the confidence level, obviously confidence level is not in our formula, but the value that is associated with the confidence level is our Z star. So to derive the formula using this set of formula that we have, we're going to isolate Z star and get rid of square root of PQ all over N. So using algebra, we'll just divide 1 over square root of PQ all over N on both sides. So 1 over square root of PQ all over N. So this will cancel out, and we will end up with the margin of error divided by PQ all over N inside the square root. And this is the Z star that we're going to be able to compute, and from the Z star we'll be able to find the area under the curve, which is our confidence level. So by substitution, margin of error is given by 0.01, we have 1%, and we're going to be using ME, P, and Q in our formula, and the value of N as well. So we have 0.01 all over P of 0.63, Q of 0.37 all over 5,594, and this is under or inside a square root, and that will be our Z star. So let's go ahead and use our graphing calculator to compute for this value. So 0.01 divided by square root of parentheses 0.63, 0.37 divided by 5594, and this is going to be equal to 1.54 or 1.55. So our Z star is 1.55. So this will help us compute for the confidence level, because we know that in a normal distribution, this will be the confidence level that we are looking for, and since the Z star is at 1.55, we have negative 1.55 and positive 1.55 for our critical value, and the area under the curve is basically the confidence level that we are looking for. So to do that, we're using second function vars, and we're using normal CDF to compute for the area between curves. So our lower limit is negative 1.55, upper limit of 1.55. 0 and 1 will be our default because we are already using a Z value. And the area that is giving, or the calculator is giving us, is 0.8788. 0.8788. Therefore, the confidence level that we're looking for, given an SRS and the margin of error, is equal to 87 or 88%. And this is how we compute or use the formula for confidence interval in solving problems involving confidence interval for population proportion.